kuliah ni nanti saya akan post supaya you boleh akses bila-bila masa lah. Okay. Okay. Saya share dulu. Okay. Okay, semua boleh nampak Okay, so today's lecture is for STKM6122. Okay, so design of experiment in food science research. Okay, I think all of you have finished your part, the part of Dr. Shuhada. Okay, that is regarding the statistical test. Okay, so just as an overall view when we do experiments. Okay, so when we do experiments, okay. Okay. Anybody having problems regarding internet access? Okay, good. So no problems. Okay, so sorry. Okay, so today is the 5th of November. Okay. Okay, so 6122. Okay, so when we do experiments, okay, okay, so we need to do statistical tests. We need to have statistics. Okay, we'll go. Why do we have to have statistics? We'll go into that in more detail later. Okay, when we do statistical tests, so the first part is design of experiment. Okay, or in short, DOEs. Okay, so how do we carry out the actual experiment in the lab is based on this one, design of experiment. Okay, so design of experiment is not only on paper, but it is the way that we should do or carry out experiments in the lab. Okay, and then when we get the data, okay, so when we do the experiment based on the design of experiments, okay, we will get data. This data, we do the statistical tests. Okay. Okay, so just to mention this so that you won't get confused. Okay, so this is what an experiment usually comprises of. Okay, so this is Dr. Shuhada. Okay, and I think I'm sure she has finished this. Okay, and this is, okay, my part. Okay, so just to let all of you are clear with this. Usually I will start first in this course, but because Dr. Shuhada is expecting, okay, so she has to finish off her part first. Okay, then I will finish mine. Okay, anyway, I think all of you have experience using statistics during your undergraduate days or during your masters. Okay, so I don't think that will be a problem. So that is why I let Dr. Shuhada start her part first. Okay, but this is just to let you know that usually this is the overall view of doing experiments. Okay. Okay, so first, before we start, I want to know your background as far as statistics is concerned. Okay, can I want each of you to state your to state your background, basically your field, okay, during your BSc, okay, or MSc, okay. Uh, uh, what is your field, okay, whether it is food science or not food science, etc. Okay, and from which university, and also whether you have taken any stats course previously. Okay. Okay. Can we start? Okay, I'll call your name and then please give me the this info. Okay. Uh, I'll start with Norin. Norin.
Assalamualaikum, Prof.
Salam.
Nama saya Noreen. My name is Noreen.
Okay.
Previously, I was graduated from UMS, Bachelor
Okay.
in Food Science and Nutrition.
Okay.
And I I had never taken any statistic course before.
Oh, okay.
Mhm.
UMS
Yes, I was graduated in 2006. 2006.
2006.
Mhm.
Okay.
It has taken
You,
long time.
I thought UMS do have statistics course?
Yes, I mean, the one that I've taken was only when I was undergraduate, and it was
Okay.
a very long time ago, almost more than 10 years. So, basically now I'm quite not familiar in statistic anymore.
Okay. It's
Okay,
okay.
thank
But
you.
you have taken the course before, right?
Yes.
During your bachelor's degree. Okay. Okay, good.
Thank you,
Okay, thank
Doctor.
you, Nurin. Okay, next, Nur Hanisa.
Uh,
Okay, Hanisa.
Assalamualaikum. My name is Nohanisa. Currently doing Master Science in Food Science. Previously, Bachelor in Food Science and Technology in UPM.
Okay.
And I've taken
Uh, Putus, Hanisa. Say lagi.
I'm in Master's coursework.
So, okay, so previously in UPM for your BSc.
Yes,
Okay.
yes.
So you have, I would assume that you have taken a statistics course during your
Yes,
bachelor.
I've taken statistics. Yes.
Okay. Okay, good. Okay, thank
Okay,
you, Hanisa.
thank you.
Nurin, tadi
Alright.
you apa tu MSc research or coursework or PhD?
MSc Nutrition in coursework.
Nutrition, eh? Okay, nutrition. Anissa tadi MSc food science, eh?
Ya betul. MSc Food Science coursework.
Coursework. Okay, okay, good. Thank you. Okay, next is Mo.
Good morning, Prof.
Hi, good
My name
morning.
is Mo Suyen. Can call me Suyen or Shane.
Okay,
Previously, I was graduated in UMP,
UMP. Okay,
bachelor's in biotechnology. So I'm not in have the nutrition background, and
okay,
currently I'm taking MSc in nutrition by coursework.
okay, okay. Your BSc was in is in which field? I couldn't get it. Sorry.
Biotechnology.
Biotech. Oh, okay. Okay. So have you taken any statistics course before?
No, but I have learned the SPSS software during my final year project.
Okay. Okay. Okay, good. Thank you.
Thank you.
Okay, so next is Nur Kamarina.
Hello, can you hear me?
Okay, yeah.
Hello, hi, good morning. My name is Kamarina. For my undergraduate studies, I did in biology, and I'll be graduating somewhere in December, 2nd December to be exact. And for my master, I'm taking food science, and this is my first semester in coursework.
Okay, so food science by coursework.
Yeah.
Okay, so during your BSc degree, have you taken any stats course?
Yeah, I
Oh,
did. I have like a multiple courses that involve statistic, but one that I remember is actually the biological statistic. Yeah, I think. Well, I
from
learned Minitab,
your BSc in which university?
UKM.
UKM. Oh, okay,
Mm,
FST lah.
yeah.
Okay. Okay. Okay, good. Thank you. Okay, so next is Nur Shafika.
Hello, Assalamualaikum, Prof.
Waalaikumsalam. Hmm.
Okay, so my name is Nur Shafika binti Salim. Graduating from USIM, background in biotechnology, food biotechnology.
Okay.
Now I'm doing master in food science coursework,
Mhm.
and I did remember learning on Minitab, if I'm not mistaken, previously back in 2010 macam tu.
Okay. Okay, thank you,
Thank you.
Shafika. Okay, so next is Mai Saidatul.
Okay, Assalamualaikum.
Salam. You student food science kan?
Ya betul.
Okay.
Okay, so
Okay. Hmm.
my name is Mai Sadatul. You can
Mhm.
call me Mai. So I am undergraduate food science and nutrition from UKM. So
Okay.
now I'm doing master.
Sekali lagi Mai. Doing master by
Master food science.
food science by coursework.
Coursework.
Okay. Okay. Okay, thank you.
Uh,
Okay, next is Capsule.
Hi, doctor. Hear me?
Again,
Can you hear me, doctor?
on and off.
On and off.
Uh-huh.
Hello, doctor. Can you hear me?
Yeah.
Okay.
Okay.
Okay, my name is Kevser. I think doktor dah kenal saya hari tu, doktor examiner saya.
Oh, yeah. Okay. Okay, Dr. Senjo punya
Yes.
student. Okay.
Okay, I did my degree in biomedical science
Mm-hmm.
from UAE Kuantan.
Okay.
I remember taking a statistical course.
Mm-hmm.
And then after that, I did my master's in pharmaceutical science,
Okay.
also from UAE Kuantan. And during my masters, I took research methodology, and I also took another statistical course during that time.
Okay.
Uh,
Okay, good. Okay, thank you.
all right.
Okay. Okay. Kenapa dia tak nampak? Okay, sekejap. Hmm. Okay. Sharing. Sharing. Okay. Okay. Okay, so Nik Farhan. Just in time. Okay, Nik Farhan, dengar saya tak? Okay. Farhan? Okay, so kita bagi dia settle down first, then we'll come back to him. Okay. 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 Okay, so thank you, everybody. Okay, so the majority of you has had one or two courses of stats course, except maybe one person. Okay, Xiu Yan, I think. Okay. Okay. Anyway, it's just for me to. It doesn't matter. It's just for me to like able to gauge the all of you the status of all of you. Okay, in this course. Okay. In this course, we are going to to discuss about statistics, the basis of statistics, and then design of experiments. Okay, up to that point. Further down, further use of statistics, statistical tests, etc. Like I mentioned just now, has been discussed by Dr. Shuhada. Okay, so if you have any problems, you can always engage her. Okay, but for this part, we'll discuss up to the point of design of experiments. Okay, and for this course, it is intended to be a review. Okay, it is intended to be a review from an application point of view. Okay, meaning that we are not going to go deep into the statistics, statistical principles, the how to calculate the sum of squares, etc., etc. Okay, anyway, with the usage of statistical softwares. Okay, I don't think any students are required to calculate. Okay, different from my time. Okay, we have to calculate manually the sum of squares, degree of freedom, etc., etc. Okay, okay. So this is intended to be a review. So regardless whether you have had a course in statistics or not, then I don't think that it will matter much. Okay, if you already have stats course previously, then it is an advantage, of course. But if you do not have had any stats course previously, then it will not be a hindrance to you in order to understand this the discussions that we are going to do in this course. Okay. If you have any problems with the internet or with anything like any questions, just interrupt me. Okay. We'll do this in an informal manner. What is important that you understand what is being discussed. Okay. Okay. Any questions? Ada? Tak ada, eh? Okay. Okay. So we can start. Okay. So the notes I have uploaded in UKM Folio. Any of you have problems with UKM accessing UKM Folio? No problems. Okay.
No problem.
No problems. Okay, good. Okay, so you can download it from UKM Folio. I put up uploaded two formats, whether you want it to be like a note or it is in a PowerPoint format. Okay. Play it. Okay. And if you need to ask me, okay, you can always email. Okay. Okay. Email me or just WhatsApp me. Okay. 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 So let's proceed with our lecture. Okay, semua dah ambil tadi, eh? Okay. Okay, so first of all, why do we need to use statistics? Okay, in food science. Okay, so for this course, okay, before I go further, okay, in this course, actually it is a wajib kursus for food science. Okay, it is an elective course for nutrition. Okay, so when we do experiments, sorry. Okay, so when we do experiments, okay, there are several types of experiments. Okay, first, there are what we call as experimental design. Okay, experimental study. Okay, types of research. Okay, or study. Okay, so first we have experimental study. Second, we have observational study. And we may have other types of studies, but these two are among the most common. Okay, among the most common. Okay, so so what this means is that, okay, for experimental study, okay, putting it simply, is that we impart, okay, treatments to samples. Basically, that's what we do. Example, okay, so example, if we want to determine, okay, the effect of heat, for example, okay, example, okay, determine, okay, to determine, okay, to determine the effect of heat on, for example, the color of blanched bananas, for example. Okay, so meaning that what we will do is okay, so we have bananas, and then we will put it in water, blanch. Blanching is a process of putting food in heated water. Okay, putting food in heated water, and the main purpose is for enzyme deactivation, because enzymes during storage, even though it is freezing, okay, temperature -20 even, but enzymes still function, even though at a lower rate. Okay, so that is why before we store or we process our foods, then we need to deactivate the enzyme. And because enzymes, as all of you well know, are proteins, okay, are made of proteins, then giving it heat will denature the proteins and render the enzymes inactive. Okay, so blanching. Then we have the bananas and blanch it, and we will blanch it at 3 different temperatures. For example, 60 degrees C, 70 degrees C, and 80 degrees C. This is just an example. Okay, so that's what we are doing. And after that, okay, and then we measure the color. Okay, for example, we are going to measure it based on the L star, A star, and B star parameters. All of this we call as color parameters. Okay, color parameters according to the CIE color system. Okay, let's say that this is what we are going to do. Okay, so this is an example of an experimental study. Okay, experimental study. We have the samples and we purposely impart a certain treatment. In this case, it is heat, okay, different temperatures, okay, on the samples. Okay, so meaning that we are in control of the samples. We are in control of the treatments. Okay, so this is what we call as an experimental study. Okay, this is being used a lot in food science and food tech. Okay, another type of study, okay, is what we call as an observational study. Okay, an observational study, as the name suggests, is based on observation, where you don't impart purposely, okay, the factors of that you want to study onto the samples. Okay, so for example, we want to determine, okay, the nutritional status in anemic children, for example. Okay, so usually what we do is we get a sample of children, okay, and these children will consist of normal and anemic, and then you measure nutritional status, right? Okay, so the difference between this study and the first one is that in this study we do not impart the treatment. Okay, we do not impart the treatment. Okay, we do not take the kids and make them anemic. Okay, so that is unethical. Okay, so we don't do that. Okay, we just what we do is we gather a sample of children. Some of them will be normal, some of them will be anemic, and then we will measure their nutritional status. Okay, okay, so that is what we call as an observational study. So it is based on observation. We do not have control, okay, on the factors. In this case, anemic and non-anemic. We do not have control over that. Okay, and we do not purposely impart it. Okay, because it is unethical. Okay, okay. So that is what is called as an observational study. Okay, so it is being used a lot in medical, in medicine, in nutrition, etc. Okay, types of DOE, for example. Okay, for this one, for experimental studies is, for example, like completely randomized design, completely randomized block design, factorial design, etc., etc. Okay, and in this observational study, for example, like longitudinal studies, okay, cross-sectional studies, etc. Okay, okay. The reason that I'm telling all of you this is, of course, for your knowledge, and also just to mention that in this course we will only discuss about experimental study. Okay, okay, because it is meant for food science, and the majority of food science research will be experimental studies. Okay. In nutrition, the majority will be observational studies. Okay, and if you need to refer, there are a few lecturers that are well versed in observational studies. For example, like Dr. Zalifa, Dr. Nolida. Most of them are in the nutrition field. Okay, however, even in nutrition, okay, you may need to use experimental studies. Okay, so doesn't mean that what you learn for nutrition students, what you learn in this course, you will not benefit you. Okay, so in certain cases, you will be required to do an experimental study. Okay, so just to make it clear, so that the approach is different. what we are going to discuss is mainly for applicable for experimental study and not for observational study. Okay, so for observational study, the approach is different. Okay. Okay, so okay, I see Nik Farhan. Nik Farhan, can you hear me?
Yes, Prof.
Okay. Okay, so we have been discussing when we start this lecture today. So can you tell me your background, your BSc or MSc field, which university have you taken a stats course previously, and what program are you enrolled in right now?
Sebelum ni saya lulusan pada USIM, degree Food Biotech.
Okay.
Lepas tu sekarang tengah pursue study untuk Master Food Science by Research.
Okay. Okay, siapa supervisor?
Dr. Haslaniza.
Okay, Dr. Has. Okay, good. Okay, and then thank you. Okay, and then saya nampak Hajar Ashikin.
Yes, Prof.
Okay, can you give me your background info?
Okay, saya dulu belajar biotek dekat UKM, biotek
Okay,
management. Sekarang saya
Biotech
ambil
Management.
biotek management. Sekarang
Okay.
saya coursework sains pemakanan.
Okay, nutrition. Okay. Pernah ambil kursus stats? Pernah kot?
Basic pernah.
Basic ya. Okay. Okay. So at least dah ada some experience. Okay. So itu adalah berkenaan dengan observational dan juga experimental study ya. Okay. Saya rasa semua dah clear. Okay, so why do we use statistics? Okay, dalam food science and technology. Okay, we greatly rely on the use of statistics up to the point that if you do not have statistics, basically you have nothing. Okay, your data, regardless of how much data that you have, it doesn't mean anything at all. Okay, there have been theses or even papers, okay, that have been rejected outright because basically the data shown do not have any statistical analysis. Okay, so in food science and tech, okay, we rely a lot on statistics. Okay, it is a must. Ini wajib ada. Okay, so mesti ada statistics. Okay, kenapa? Kenapa kita guna statistics? Because food science and tech is an integrated and applied field. Okay, first and foremost. Okay, when we talk about food science, it is very integrated and applied. Okay, dalam food science, in food science, we have physics, engineering, chemistry, biology, molecular biology, all the sciences, mathematics. Okay, and we do also incorporate. There are components of food science that deals with other non-science fields. For example, religion, okay, halal, for example. And then also dari segi budaya, okay, functional foods, for example. Okay, so all of those, okay, are in components of food science and technology. Okay, so we need statistics in order for us to navigate our data, the understanding of our data among these different fields. Okay, and also it deals with biological samples. Okay, when we deal with biological samples, then we have to expect a higher degree of heterogeneity in our samples. Okay, a higher degree of heterogeneity in our samples. Okay, take for example, if we were to go to a sekolah rendah, okay, year one students, okay, all of those in the year one students, okay, are the same age, approximately born within the same year, and even if we took the same jantina, lelaki ataupun perempuan, okay, even though they are all the same, but if we were to look at their weight, for example, it will be different. Right? It will be different. Okay, in food, for example, if we take apples, okay, if we take apples, that among, even though the apples have been approximately the same degree of maturity, okay, when they are harvested, but still they are not the same. Okay, so biological samples rarely have a high degree of homogeneity. Okay, different from chemistry, for example. When they do experiments, they will use, okay, samples that are like very pure, 99.9%, for example. So the degree of heterogeneity is very low. Okay, but in biological samples, okay, in food, then we have a very high degree of heterogeneity. Okay, so when we do this, when we have this, okay, for example, when we want to measure, okay, when we want to measure, for example, the moisture content, okay, the moisture content of bananas, okay, what we do is we will take a few bananas, okay, and then we will slice them and then put them in a dish, weigh the dish, and then put in the oven overnight, okay, and then tomorrow morning we will take them out, okay, cool it down in a desiccator, and then reweigh it, okay, and then we will measure the moisture content, the difference, okay, between the previous and the current weight, okay. If you were to take the same banana and do two measurements, we will not get the same. We will not get the same moisture content, right? Okay, that is due to the heterogeneity of the samples. Okay, so if we were to take two bananas, okay, even though they are of the same degree of maturity, two bananas, okay, and we measure the moisture content, still we will not get the same data, okay, the same results, right? Okay, so if, okay, for example, okay, like this one, okay, we take bananas, okay, banana 1, and then this is banana 2, and then both we measure the moisture content. This also we measure the moisture content. Okay, same methodology. Okay, for example, AOAC. AOAC. This also AOAC. Everything is the same, but we will get, okay, we will get, okay, we will get different data, X1 and X2, where X1 is not the same as X2, right? Okay, so why? Because of the heterogeneity of the samples. Okay, we cannot expect all the samples of all the bananas to be exactly the same. So it is different when for example, in chemistry or in physics, where we are dealing with a more pure, a more homogeneous type of samples. Okay, so this is the what happened. Okay, then for example, going back to our example here, okay, we blanch. Okay, we blanch at 60, 70, and 80. Okay, so now we have the 60 degrees C, 70 degrees C, and 80 degrees C. Everything is the same, the type of banana, degree of maturity, the dimensions of the samples, everything was the same. And then we will get, for example, X60, the result. This is X70, and this is X80. Where, for example, we get X60 is not the same as X70, for example. Okay, can we say that that the different temperature is having an effect on the moisture content? Difficult, because if the answer is yes, because it is not the same, if the answer is yes, then even when it is the same, everything is the same, even then we do not get the same results, right? So when we get a difference over here, okay, is it because of the different treatment or because of the heterogeneity? Okay.
Because of heterogeneity.
So how do we know? How do we know that it is because of the different treatment, or is it because of the heterogeneity? How do we know?
Because
The
the
way.
first one, because the first one we give the same treatment, still the moisture content is not the same. Whereas the second one, we give the different treatment, also we don't get the same. So the result is the same. So it is not because of the treatment given to the bananas, but because of the heterogeneity of the bananas.
Okay, good. But there is always a possibility that it is because of the treatment, right? Okay, just because the samples are different, okay, because the samples are different, so it may be because of different treatment. Okay, because the samples are different, but it may also be because of heterogeneity. So how do we determine whether when we get a different treatment, because of the treatment or because of the heterogeneity? That is why we have to do statistics. Okay, so that is why we have to do statistics. Okay, because different results will always be different. But what we want to determine is whether that difference, if the results are not different, then no problem. Okay, but if it is different, okay, then whether those differences are due to the heterogeneity of the sample, which is an inherent property or characteristic of the sample, which we cannot change, okay, or it is because of the different samples, right? Okay, so that is why we need to do statistics. Okay, we cannot compare just numbers by numbers only. Okay, if, okay, for example, we do, because this is 2, okay, we do a t-test. Okay, we do a t-test, and the t-test came out no significant difference, meaning that even though we see a difference over here, okay, so even though we see a difference over here, this one, okay, the difference is due to the heterogeneity of the sample. No significant effect of treatment. Okay, so no significant difference. No significant difference meaning that there are no significant effects of the treatment, even though this one is different. Okay, even though it is different. So why is it different? Because of errors, heterogeneity of the samples, etc., etc., but not because of the treatment. Okay. Okay, so that is why when there are no significant differences, okay, we cannot say that these two are different. Okay. If okay, t-test says that have significant difference. Okay, then only we can say that, okay, this difference is because of the treatment, that is the different temperature, and not because of the heterogeneity of the samples or any other errors. Okay, so that's why when we do studies in food science, we have to do statistics and we have to see whether there are significant differences or not. Okay, okay. Any questions? Okay, so that's why we need statistics to determine whether difference in results were due to the treatments or the heterogeneity or errors. Okay, so it is not enough to only look at the numbers, to only look at the means. Okay, we have to do a statistical test. Okay. Okay, and then what are the function of statistics? Why do when we use statistics, for what do we use statistics? Okay, several functions of statistics in food science. Okay, among them are first and foremost, of course, to digest data. When we do experiments, okay, we only get numbers. Okay, we only get numbers. Okay, the thing is that what do the numbers mean? Right. Okay. When we measure our samples, we get numbers. So we need to convert those numbers into information. Okay. Convert those numbers into information. Okay. Then only we can get the understanding. Okay. The reason, the purpose of doing studies is to get understanding, produce new knowledge, new understanding of our system. Okay. Okay, example are like data characters. Okay, the distribution, the accuracy, logic, trends, etc. All of those are information that we get, okay, from digesting data. Okay, and then we also get the meaning of it. Okay, the meaning means the direct information, whether it is high or it is low, it's a maximum, it's a minimum, etc. Okay, and then also the inference. The inference is the indirect data. Okay, if it is different, what is the meaning or the possible cause of the difference? Okay, and any relations. If it is high, then okay, what does that imply? Okay, those are all inference. Okay, indirect data. So all of this we will get when we digest our data. Okay. Okay, so nature of statistics. Okay, when we want to use statistics, we have to understand the nature of statistics because if we do not know the nature of statistics, because statistics are not perfect. Okay, it has its weaknesses and its strengths and also its limitations. So we should not use statistics beyond its limitation. Okay, so then it will not give us the correct information. Okay. Okay, so nature of statistics is that it is not based on exact facts because we do not have the information. We do not have the exact facts. Okay, for example, like if we want to determine, okay, the average weight of the students in this course, okay, then what we do is usually, okay, we measure all the weight of the students in this class. Okay, for example, there are 10 students, okay, all 10 students, and then we total it up, okay, and then we divide it by 10. So that will be the average weight, okay, of students in this class, right? Okay, so that is what we call as a population mean. Okay, the population mean, because we measure each and every individual in the population. In this example, the population is the population of students of this class. Okay, so we measure each and every individual, and then after that, total it up, and then divided by the number of individuals. Okay, so that is exactly the population mean. Okay, and it is exact. Okay, okay, so however, okay, if you want to measure the weight of a banana, okay, the weight of a banana, okay, reduce it to a certain type of banana. For example, banana pisang nipah. Okay, pisang nipah, a variety of banana. Okay, for example. Okay, so can we measure the population mean? The answer is no, because there are so many pisang nipah. Right, there are so many pisang nipah that it is not possible for us to measure each and every individual of the pisang nipah population. Okay, so to determine the population mean is impossible. But in doing statistics, we need the population mean. So what we do, usually, we will estimate the population mean. So it is an estimated population mean. So what we do is we take a few samples and then we measure it, okay, and then we get the average. 5 or 6 samples, and then we measure it, and then we get the average. So that average, okay, so that average, okay, so the first is the population mean. Okay, this is exact. Okay, and then the second is the estimated population mean. Okay, this is based on estimation. Okay, measurements of samples. Yang ini tadi measurement of every individual. Okay, so estimated population mean. So when we estimate it, is it going to be exactly exact? Is it going to be the truth? It may or may not be. That's why it is an estimated mean, right? So the nature of statistics that it is not based on exact facts, because it is impossible to get exact facts. So we have to be content with estimations. Okay, and then another nature of statistics is that it is based on assumptions. Okay, based on assumptions, for example, the population follows a normal distribution, for example. There are formulas to measure this, okay, but still it is based on assumptions, okay, because we cannot measure each and every individual in the population. Okay, so it is based on assumptions. Okay, and because of that, when we conclude, okay, the conclusion also is based on probabilities. Okay, it's based on probabilities. Okay, so that is why okay, sorry. Okay, so that is why, okay, when we conclude, okay, we always have to look at the confidence interval. Okay, all of you have had this experience, okay, where we say when, okay, it is significantly different, okay, p less 0.05. Okay, so when we say that it is significantly different, we always have to put this is wajib. Okay, because coming back to what we have discussed just now, okay, the conclusions are based on probability. Okay, it is probable. We do not know exactly, even though we say that this is different, but it is probably different. Okay, how probable? 95% probable. Okay, how probable? 95% probable. That is why it is 0.05. That is 95% confidence interval. Okay, so that is statistics. Okay, so we have to know the limitations. Okay. In why do we use 95% confidence interval? Because it is common practice in food science. Okay. In other fields, they can use up to 99%. Can it be 100% confidence interval? The answer is no. It cannot be a 100% confidence interval. Okay. Okay. Basis of experimental statistics. Okay. First is assumption. Okay. So this we have discussed just now. Okay. Population follows a normal distribution. Okay. Okay, a little bit about normal distributions. Okay, this is important for us to understand. Okay, of course, we say that this is the normal distribution. Okay, what is the characteristic of a normal distribution? Is that it is bell-shaped. Bell-shaped meaning that it is high. Okay, sorry. Okay, it is okay. So this is the normal distribution. Okay, so it is the high point is in the middle. Okay, it is in the middle. In any parameter, the height or the weight or anything. Okay, and this is the percentage, for example. Okay, the percentage of the population. So this is 50%, for example. So low population at the peripherals, at both ends, but very high. Okay, population at the middle. This is the sorry. Okay, so this is the mean. Okay, so that is the mean. Okay, so this is low, okay, and high at the population, meaning that the majority of the population resides around the mean. So this is critical, okay, for you to understand. Okay, so if, for example, if I were to take at random one individual from this population, what is the probability of taking an individual from here? Low or high? The answer is low, right? Why? Because the number is low, right? Only a certain percentage only. Okay. For example, like if I were to pick an individual from this class, okay, what is the higher probability? I will get a male student or a female student? The answer will be a female student, because there's only one male student inside this class, inside this course, right? Okay. So because the majority of the population resides around the mean, okay, that's why it is bell-shaped. Okay, and that is also why when I took an individual at random, okay, the higher probability is that that individual will come from area around the mean. Okay, it will come around the mean. Can it possibly come from here or from here? The answer is yes, but the probability is lower. The probability is lower. Okay. Okay, so normal distribution, and then probability and confidence interval. Okay, decisions are based on probability. We have discussed this just now. How probable that mu1 is equals to mu2? How probable is mu1 is not equal to mu2? Okay, so due to the heterogeneity of real life populations being experimental, we have discussed that also. Okay, because of the heterogeneity. Okay, so it has to be based, our decision has to be based on confidence interval. How much do we want the confidence interval? Okay, if we want it to be 99%, so that we have to state that we are using a 99% confidence interval. So that is why, coming back to what we have discussed just now, when we make a claim, okay, when we make a claim, okay, when we make a claim, when we say that significantly different, okay, when we say that it is significantly different, okay, this is a claim, okay, that is a claim. Okay, this claim has to be followed by the syarat. Okay, the syarat is that it is 95% confidence interval. If we were to change to 99% confidence interval, will this still apply? The significant difference? May or may not. Okay, so that is why this claim, significant difference, means nothing without this syarat. Okay, so that is why when you write your thesis, your supervisors always mention that you have to put this. This is not for show only. So it is a syarat. It is a technical, technical aspects of this claim. Okay, okay. Okay, so and then that's why we need to state the confidence interval being used. Okay, so that we have discussed this now. Okay, let's look at the components of experimental statistics. Okay, first and foremost, of course, we have to start with the hypothesis. Okay, when we do our experiments, okay, when we do our experiments, okay. Okay, when we do our experiments, how do we conduct experiments? Okay, first and foremost, it starts with the problem statement. Okay, what is the precursor or the driving component, driving force of doing an experiment? Is that it starts with a problem statement. What do you want to study? What is the problem? Okay, for example, like bananas just now. Okay, when we blanch bananas, okay, the texture is too soft. Okay, the texture is too soft. So that is the problem statement. So we want to determine the effect of temperature on the texture of the banana, for example. Okay, so it will start with the problem statement. Okay, then after getting the problem statement, okay, then we start with the research hypothesis. Okay, research hypothesis. Okay, so we say that, okay, maybe the different, the heat is giving an impact on the texture of the blanched banana. So we need to determine the effects. Okay, so that is the research hypothesis. Then based on this research hypothesis, then you determine the research objectives. Okay, so research objectives. Okay, and then based on these research objectives, then you determine your design of experiment. Okay, design of experiment, and then do experiment. Okay, you get your data, and then statistical test. And then when you get that, you analyze. And then you discuss. Okay, so that's what we do. Okay, this is the knowledge generation pathway. Okay, to put in a simplified form. Okay, so when we discuss, then what we get is knowledge. Okay, okay. So you need. I really want to stress this, that students really should understand. Okay, should understand their problem statement. This one. A lot of students do not understand the problem statement. Okay, because the thing is that because the title of your projects did not come from you. It comes from your supervisors. Okay, it comes from your supervisors. Your supervisor has gone through this thought flow. Okay, from the problem statement to the research hypothesis to the objectives. Okay, it has gone through this thought flow of your supervisor, because it is their title, right? It comes from them. Okay, but you do not. You did not. Okay, so you only get your title over here, and then you go for the objectives, etc. Okay, when that happens is that when you present your proposal, you cannot rationalize why are the objectives like this, why are the design experiment like this. Design experiment mean your factors, your responses. Why are you measuring this and not that? Okay, because you do not understand the problem statement. Okay, because you just parachuted in, jump at this point, forward, onwards. Okay, okay, so that is why my advice to students is that you need to understand the problem statement. Okay, don't only look at the title and the objectives. Understand the problem statement, even though it is not your title. Make this problem your problem. Okay, okay, so that when you have underwent this thought process, then you understand the problem statement, research hypothesis, then understanding objectives will be easy. And then to rationalize the DOE easy. Okay, etc., etc. Okay, okay, so understand the problem statement. Okay, and then when you want to do when you want to analyze your data, and then when in statistical test, we always have the hypothesis. Hypothesis. This is not the research hypothesis like this one. Okay, this is the research hypothesis. This one is a statistical hypothesis. Okay, so when we want to do run a statistical test, so we have to have hypothesis. Okay, the first is the null hypothesis. The second is the alternate hypothesis. The null hypothesis is mu1 equals to mu2 equals to mu3, meaning there are no significant differences. Okay, alternate hypothesis, meaning that at least one mean is different. So if you have mu1, mu2, and mu3, mu means the mean. Okay, mean of 1, mean 2, and mean 3. Okay, in our example, the mean of heating at 60 degrees C, the mean for the texture of banana heated at 70 degrees C, and also the mean for the texture of the banana blanched in 80 degrees C. Okay, so that's what it means. Okay, for the alternate hypothesis, at least one mean is different, meaning that among the three, for example, in this example, you only have 3 means, you can have more. Okay, at least one is different. Okay, so that's what it means. Okay, so we always have to understand the hypothesis, so that when we conclude, okay, we want to infer our data, okay, then we know what is the understanding. Okay, okay, and then another component of statistics is of randomization. Randomization is very, very important. Okay, randomization is very, very important, but usually this is the most commonly left out component of doing experiments. Okay, experiments. Okay, so when we do experiments, okay, the purpose of doing experiments, among others, is to generate knowledge, right? To generate knowledge, we want to generate new knowledge, new understanding. Okay, and usually we will be dealing, when we do research, we will be dealing with unknown systems or unknown population, especially in the postgraduate level, master's, PhD. So this is what we call as the novelty. Okay, the novelty means that it is something which is novel, which has not been done before. Of course, novelties have different degrees. a totally novel approach, for example, a totally novel system, for example, or it can also be an incremental degree of novelty. Okay, so doesn't matter as long as there is novelty, because in academia, okay, in the universities, we are our business is to generate new knowledge. So that is why novelty is important. If we are in the industry, in the production, the production of tomato sauce, for example, so the emphasis is on uniformity. Okay, we do not want novelty, right? Okay, in the daily production. Okay, novelty in the R&D is fine, but in the daily production, we want to have uniformity. We don't want the customers to be surprised that our tomato sauce tastes different, right? We want, because we want them to always have that that experience that they expected when they consume our tomato sauce. Okay. Okay, so when we do novel experiments or novel studies about novel aspects or systems or populations, then variability definitely will exist, errors will also exist, unknown factors also exist, because regardless of how much knowledge we have, when it is a new system, new things, then we cannot claim to know everything, because it is new. That's why it is new. Okay, so that is why we need to randomize to minimize bias. Okay, minimize bias. Okay, so that we can produce a more level playing field, so that our data will be more reliable. Okay, with minimized bias. Okay. Okay. What does randomization means? Okay, for example, okay, if we go back to our blanching experiment, okay, so we have 60, what are the factors? The factors are the aspects that we want to study. Okay, that we want to study. Nowadays, in sekolah rendah and sekolah menengah, also they have taught this. Okay, the factors are the apa nama dia, pemboleh ubah yang di apa, manipulasi. Pemboleh ubah yang dimanipulasi. Actually, those are the factors. Okay. The simplest approach to doing an experiment. Okay, simplest approach to doing experiment is that, okay, for example, if you want to determine the effect of heat. Okay. Okay, objective. Okay, to determine the effects of heat. Okay, on banana, etc., etc. Okay, like the previous part. Okay, then we want to determine the effect of heat. Okay, so what are the factors? Factor is the temperature, blanching temperature. Okay, blanching temperature, meaning that everything is the same except the temperature. Okay, the banana, okay, banana slices, the dimension has to be the same. Okay, the amount of water for blanching, it has to be the same. The container, it has to be the same. The source of heat, it has to be the same. Everything is the same except the factor. Okay, then and then only when we get that, okay, mu of 60 is higher than mu of 70, then we can say that this is due to the factor and not to other things. Okay, because when the rest, for example, the amount of water is not the same, then the question arises, is this due to the blanching, okay, to the temperature, or is it due to the difference in volume of water? Okay, so that's why when we do experiments, everything has to be the same. Itu yang dinamakan pemboleh ubah yang dimalarkan. Kan? Pemboleh ubah yang dimalarkan, if any of you remember. Okay. Okay. So okay. Okay. So the factor is the blanching temperature. Okay, and then factor ini, when we want to determine the effects of certain factors, then we have to vary the factor. We cannot say that we want to determine the blanching temperature, but then we only do 60 degrees C. Then it is not, it is a constant. So when it is a constant, we cannot determine its effects. So we have to vary it. Okay, for example, 60 degrees C, 70 degrees C, and 80 degrees C. This we call as the levels. Okay, we call this as the level. So the factor, blanching temperature, the levels, how many levels of temperature? 60 degrees C, 70 degrees C, and 80 degrees C. So 3 levels. Okay, and then what are the treatments? Treatments are, it is a one factor experiment. Okay, because only one factor. Okay, so the treatments are, of course, 60 degrees C, 70 degrees C, and 80 degrees C. Okay, okay, so those are the treatments. And then when we have blanched the bananas, then we want to measure the texture. So the texture is the response. That is the texture analysis. Maybe, okay, for example, like compression test, etc. Okay, okay. So our treatments, we have 3 treatments. Okay, and then we also have replications. So we say that we do 3 replications. Okay, we do 3 replications. So how do we go about doing it when we are in the lab? Now you go into the lab. Okay, you have your bananas. Okay, how do you prepare it so that you are going to blanch it? Okay. Okay, so commonly, because students in science is being taught to be systematic, which is good. But in carrying out experiments, okay, we do not want to be systematic, because when we do it systematically, then there will be bias. There will be bias. Okay, so usually what students will do is that, okay, so first they will do for 60 degrees C. Rep 1, Rep 2, Rep 3. Finish. And then they will do 70 degrees C for Rep 1, Rep 2, Rep 3. Finish. Then they will do for 80 degrees C. Rep 1, Rep 2, Rep 3. Finish. Okay. Even though it looks systematic, very systematic, but we do not want this, because when we do this, then there will be biases. For example, like if you were to do 60 degrees C first, okay. For example, if that day the humidity is very high, for example, then there will be less evaporation of water. So all the 60 degrees C samples will be exposed to that condition. And the next day, when we do the 70 degree sample, all of these samples will be exposed to another condition. Similarly, to another lab condition, okay, surrounding condition. Similarly to 80 degrees C, it may be exposed to another totally different surroundings. Okay, so it may affect the data. Okay, so that is where the bias will come in. Okay, so that's what we do not want. We want all the samples to be exposed to the same. Okay, all the treatments is being exposed to the same conditions. Okay, same probabilities. Okay, so what should be done is, for example, okay, if you want to do Rep 1 first, okay, this is what we call as a completely randomized plot design. we will go into that later. Okay, but for example, we want to do a rep 1 first. Okay, rep 1. So rep 1 consists of 60 degrees C, 70 degrees C, 80 degrees C. Which one do we do first? Then you have to randomize this. Randomize means you rawatkan dia. Okay. How do we do that? We can always use the computer, because inside the computer there is a randomized number generator. Okay. Or because it is only 3, we can just write on a piece of paper 60, 70, 80, and then cabut undi. Okay. And then pick straws. Cabut undi. Okay. For example, the first one comes out as 70. And then the second one comes out as 60. And the third one, of course, is 80 degrees C. So in the lab, you do this first, this second, this third. Okay, that's what is called as randomization. For rep 1. For rep 2, don't follow this sequence. Okay, another randomization sequence. Okay, pick straws again. Okay, maybe this time around, it will come out as 80 first, 70 second, and 60 third. Then in the lab, for rep 2, you do this. Similarly, for rep 3, you randomize. Okay, so meaning that for 60 degrees C, okay, sometimes it is being done second, sometimes third, sometimes first, for example. Okay, so if there are any confounding factors, all the samples will be exposed equally to the confounding factors. Because remember, okay, we are doing experiments on a new system, okay, or new samples. Okay, so the possibility of a factor that we do not know of that may affect our data will always be a possibility, right? So that's why we have to do randomization as a safeguard to minimize the bias. Okay, to minimize the bias. Okay, so that is what randomization. So when you go into the lab, you have to randomize, okay, the sequence of doing experiments. Okay, so that there will be no bias. Okay. Okay, that is randomization. Okay, and then of course replication. Okay, replication. Why do we do it? Okay, all of us are familiar with this replication. Okay, so basically it comes down to what we have discussed just now. Okay, the normal distribution. The normal distribution. Okay, so okay. Okay, so for example, if you have this normal distribution, like I mentioned just now, if you were to pick one, okay, sorry, remember, we want to estimate the population mean. Why do we want to estimate the population mean? Because we cannot measure the population mean, because it is not practical. For example, like just now, we want to measure the weight of a banana. So it is impossible because there are so many bananas in the world. Okay. Okay, so what we want to do is to estimate the population mean. For example, this is the population mean. Okay. In this case, we know. Okay, just for example. Okay, we have this population mean. Okay, and then usually we will take samples, right? We will take samples, and that sample we will average it out, and that average is being used as an estimated average of the population mean. Okay, so if you were to take only one individual to represent the estimation of the population mean, it may come in. We may pick one from here. Most probably, we will pick one from here, right? But there is also a possibility that it is from here or from here, right? Okay, but okay, if we were to take two individuals, then it increases the probability that what we will pick is from around here, because the majority of the individuals are around here. So if you were to take only one, okay, then we have a lower probability. But if you were to take two, then we have a higher probability of taking individuals around the actual population mean. If you take three, then it is a higher probability. Take four, and so on and so forth. Okay, so that is why we need to do replication, okay, to increase the possibility, okay, of getting close to the actual population mean. Okay. Okay. Okay, and then we have the mean and standard deviation. What does mean means? Okay, basically means are averages. Okay, but more importantly is the story behind the mean, because mean is so commonly used and so convenient that sometimes we overuse it or we abuse it. Okay, so we have to understand the story behind the mean. The story behind the mean is that it is not the whole story. Okay, so it needs to be complemented with standard deviations. Okay, jangan terlalu taksub kepada mean. Okay, do not focus too much on the mean. Mean is a convenient measurement, but it is not the whole story. Always complement it with standard deviation and also with statistical tests. Okay, with statistical tests. Okay. Okay, so the standard deviation, it gauges the distribution of data. Okay, will show the range where the mean is possible. Okay, usually dalam bentuk plus minus tu. Okay, contohnya, it is a graph without error bars. Okay, tapi bila kita ada standard deviation, we can put in error bars. Okay, so it not only shows that where the mean is, but also the data range distribution. Okay. Okay, ada apa-apa soalan? Okay, jelas semua. Okay, so dengan itu tamat kita punya perbincangan berkenaan dengan the basics of statistics. Okay, next lecture will be about the design of experiment. Okay, okay. Tapi sebelum tu saya akan bagi you assignment. Okay, the assignment is a simple assignment about replication. Okay, saya akan uploadkan dia. Okay, so minggu depan tidak ada lecture, no lecture for next week. Next week, use the time to do your assignment. Okay, to do your assignment. It is an individual work. You have to put in to submit individual reports of the assignment, but the data is a collective data. That is the weights of all the individuals inside this course. Okay, the purpose is to show to you the effect of using replication. Okay, the effect of using replication. Okay. Okay, ada soalan lagi?
Doctor, I have a question. Actually, I did statistics before, but this is an eye opener lah, because I think this is the first time I'm hearing about the DOE. Just now you gave the example of how you do the replicates, the 60-degree, 80-degree, and the 90-degree. I didn't know that was how you actually did it. So it's very interesting.
Okay. Okay, good.
Because I don't know why I don't remember learning that. I remember learning all the tests and all the statistical part, but I was not actually exposed to that. So are you going to go deeper into that design of experiment later?
Yes, because
CRD, CRBD.
yes, definitely. In our future lectures.
I see. All right. Okay.
Okay.
All right.
Okay, good. Okay, any other questions? Okay, so if there are no questions, we'll stop here for today. Okay, so see you again in 2 weeks time. Okay, so I will upload the assignment, okay, in UKM Folio, okay, and it is due on the 19th, okay, before, sorry, on the 18th, okay, because on the 19th, we will discuss the assignment. Okay. Okay. Thank you all. Okay. See you again in 2 weeks time, inshallah. Okay. Assalamualaikum.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.
Thank you,
Thank you,
Prof.
Prof.
Thank you, Prof.
Okay. Welcome.